All right. Welcome, everybody, to MedSecurity's fourth Maritime Town Hall. My objective is to present timely and relevant topics in maritime and also bring in experts from time to time to discuss those topics. A good maritime phrase is a rising tide raises all boats. And with this series, I'm hoping to contribute to that rising tide in a meaningful and collaborative way. A lot of you may already know me, but I'm a retired Coast Guard officer. My career in the Coast Guard was very heavy into IT and cybersecurity. It's not just a job for me, it's a hobby and a passion. So I continue to work in cybersecurity personally and professionally. Um, I'm just trying to raise the bar here for the maritime cybersecurity community and bring folks together to solve a challenge that I've been a part of for decades. So today we're going to talk about smart ports. What's a smart port? Essentially, a smart port is one that takes advantage of emerging technologies such as artificial intelligence, Internet of Things, blockchain, and automation to get efficiencies and enhance safety and security. It's important because this is a very highly competitive market and environment. And with 80 to 90% of goods operating in the maritime transportation system, the problem becomes even larger. So the maritime transportation system is a highly complex system of systems. Maritime is hugely complicated. It's both multidimensional and multivariable. So what you have is you have your ships with their own bandwidth and communication services. With the advent of Starlink and coastal cellular and other high bandwidth, low latency services, it's made their capability far more formidable. And just like we have smart ports, we're moving towards smart ships and an entire smart ecosystem. So shipboard networks, operational tech systems such as navigation, propulsion, cranes, and luring systems are being increasingly networked. Pumps can be Wi-Fi connected. Environmental concerns are making automation even more attractive. We also have shipping lines. We optimize cargo carrying and gas mileage because that becomes a factor. And then you also want to optimize your personnel costs. So automation also will help with reducing personnel costs in many cases. You have people such as vendors, trading partners, governments, customers, dredging operations, aids navigation, maintenance, including predictive maintenance. Then you have the ports themselves with RFID, with crane operations, cargo tracking, intermodal, from ships to railroad to trucking to barges and airlines. So I want to point out that an issue in any one of these nodes can bring a port to its knees. Optimization is of course a great challenge to solve, but what I want you to think about is what happens if one or more ports become inoperable and the massive computation that it takes to determine how to best overcome that challenge. Because any one of these things in one port or two ports make this very, very difficult for a human to solve. So we have multiple challenges, as I mentioned. One is high inefficiency and declining productivity, which leads to long vessel wait times and cargo handling costs. Limited digital literacy in the sector. So there's a lot of competition for artificial intelligence knowledge and implementation. We're constrained on unreliable electrical systems in some cases. We have limited high bandwidth availability across the country. So you may have large bandwidth in certain places, small bandwidth in others. And so being able to make sure that the intermodal is taken into account is also a piece of the puzzle. There's also a lack of urgency surrounding port cybersecurity frameworks. We have environmental, labor, and political and economic sensitivities as well. So the problem is not just an economic one. There's political sensitivities, there's economic sensitivities, there's competition. All of these things make the maritime transportation system a very difficult and complex problem to solve. And so that's where artificial intelligence, blockchain, Internet of Things all kind of come together to help simplify that challenge. So the objectives with smart ports are to reduce the time ships spend in ports. A ship in port is offloading. The quicker it can offload, the more efficient it is. Lower operational costs with reduced fuel, with better routing and better transportation systems, better consideration of gas mileage. Safety is always a paramount concern to make sure to protect your cargo, your port facilities, and the people that are in them. Sustainability, security, and resiliency, being able to recover. If one port goes down, is there another port you go to? Does that happen automatically? How do you determine what goods go to what ports? So the objective is to use artificial intelligence and smart computers to be able to make these calculations quickly in the event that you have some type of disruption within the ecosystem. So how does technology transform ports? We're going to go now into some of these buzzwords and talk about them a little bit. So artificial intelligence can be used to predict trends, optimize schedules. It can learn and analyze all the different data that comes in and optimize how you perform under certain conditions. They can also use for preventive maintenance in order to prevent negative issues from coming to reality. Internet of Things or sensors that are placed on ships. They can provide real-time data so that you're able to understand what is happening in the present time on your platforms, in your ports, with your systems, so that you can make informed decisions if a change needs to be made. Automation can reduce errors that the humans can introduce. Self-driving trucks, automated cranes, we're seeing those in multiple ports more and more. Big data analytics helps with taking input from multiple ports and the entire ecosystem and analyzing those trends, not just within each port to optimize it, but to optimize it across the maritime transportation community. And what might be suboptimal for one port might be optimal for the entire maritime transportation system. So those data analytics can help with analyzing your trade-offs as far as what types of decisions you need to make and how you factor those in. It also moves us away from outdated paper systems and streamlines communications between all the different communication nodes within the ecosystem. So some of the terms that you may have heard and that I want to define here are one is digital twin. And effectively, a digital twin is just a virtual environment that's a model of an existing port. So you can make changes in a simulated digital twin that you don't have to bear out in reality. And that allows you to make those changes, those hypothetical changes, and model what the impacts will be. So that becomes a very powerful tool for making sure that you don't so that you don't implement something that has unintended consequences. So if you can make a change and model it in a simulation as opposed to the real world, you're going to reduce safety risks, you're going to reduce efficiency costs, and be able to introduce more hypotheticals into it. So when you hear the term digital twin, it's just basically a simulated environment that's designed to model what an actual port or platform looks like for modeling. You have autonomous drones and robots. Those are basically just self-driving. Drones are used for inspections and real-time monitoring to save the cost of people and also expand your coverage, because drones can cover a lot more ground than people can. And then green ports is a term where future ports will focus on reducing their carbon footprint. So when you hear about a green port, it's one where they're concerned about reducing the amount of carbon that's being released and trying to become carbon neutral and smart systems that optimize energy use. So these are terms that you'll hear quite a bit, and hopefully that's helpful in defining what they are. So some of the issues with automation, of course, first one is cybersecurity risk. If you're dealing with pencil and paper, very little cybersecurity risk. But with increased digitalization, that means that more people have potentially access to those endpoint devices. They're more exposed to cyber attacks, and hackers could target port systems to cause delays or to steal information. Ransomware and other types of things become into play in areas of the maritime transportation system that they weren't able to infiltrate before. The next is high setup costs. Clearly, any kind of technological recapitalization requires investment up front, and that's why we're seeing a lot of the larger ports, Rotterdam, Port of Virginia, some of those that are leaders in that, because they may have the capital to be able to reinvest in their systems and automate for a long-term risk of investment. The next one is integration issues. So if you have old systems that are in place, you have to make sure that the new systems are compatible with them and work with them. So sometimes that requires a lot of effort up front to make sure that you're not going to be installing some type of new system or technology that is going to cause you to have to update those older systems that you hadn't counted on doing. And if you can model those and get those answers up front, it'll save you a lot of time on the backside. The next is impact on jobs, and this is a critical one because there are a lot of personnel and their livelihoods could be impacted. Automation could reduce the need for manual labor, and so sometimes there's sensitivities around that about retraining your workers to work within this high-tech environment, to allow them to make their livelihood in a different manner that's more optimal for the maritime transportation system. But clearly, that also can result in resistance to going to these technological advances because the folks that are doing those are incentivized for their livelihoods to maintain the status quo. So there has to be very smart, very deliberate study into how your workforce is going to be impacted by the integration of these new technologies. So some of the practical use of artificial intelligence in smaller ports, maintenance needs are a big one. And if you can figure out if you can get more time out of equipment based upon how it's operating and based upon its current status, then that allows you to extend the life. If you see something that's deteriorating before then, you can use artificial intelligence to tell you that you need to replace something maybe before it's time, before it's mean time to repair in order to avoid any kind of failure and costly delays. It's also used to manage ship traffic. So when you're scheduling ships, there's a lot of complications there. Not all ships arrive exactly when they're supposed to, and so how does that impact the overall scheduling of the terminal or the port that you're in? The next is improving security. So you can use AI cameras to monitor ports and to be able to detect movement and other types of unauthorized access that might be going on, unusual activity, any anomalies. Computers are better at seeking those out generally than humans are, or you can use both to get the best of all worlds. The next is, of course, efficient cargo handling to determine the best way to stack the containers based upon their weights and everything else. And again, those aren't easy calculations to do with pencil and paper or spreadsheets. If you can utilize AI to optimize your cargo handling, then you'll be in a better situation. The next is environmental benefits. So if you can monitor your air quality and emissions, that helps you get to that green state where you're reducing emissions, less impact on the environment, and better overall operations and efficiency for the ports, in addition to making things more environmentally friendly. Blockchain is another word that gets bannered around quite a bit. And so the way that blockchain works is there's a digital ledger, and it makes things secure because it records every transaction. You can't delete that transaction. And when they store it in a block and it's linked, hence the term blockchain, to previous transactions, you have an unalterable chain. Or if somebody tries to alter that, it's very easy to recognize. The next advantage of blockchain is decentralization. So as these ledgers are being done and shared globally, if something goes down someplace, then the decentralized nature makes sure that no single party can alter information without everybody else knowing that it's been done. So it makes it more tamper-proof. And then finally, you have a consensus mechanism. So for any transaction such as cargo handover or customs clearance, it must be verified and agreed to by multiple parties. You can have where it requires, two-factor authentication, for instance, where this entity and this entity have to agree that a transaction has been done digitally to verify that it has in fact been done. So it's kind of a separation of duties and make sure that not one individual has the ability to make some type of change accidentally or on purpose that might impact the transaction. So ports handle an enormous amount of paperwork, and I've listed some examples here. And the manual processes are very time consuming. And so blockchain digitalizes these documents and makes it less likely that they can be tampered with. And it can happen more quickly than it can with pencil paper, with other means, emailing things, or even within applications. So a real world example here is a shipping company can upload its bill of lading Customs officials, port authorities, logistics providers can access securely, so you don't have to have physical copies. So it's all in one place. That's able to be verified by all the different parties. And if somebody sees something amiss, they can stop the kill chain of badness that can come with something accidentally being done. So, and one of the probably the world's most advanced smart port is the Port of Rotterdam, and there's 14 million 20-foot equivalent units of cargo annually, and that's a lot. So they have a digital twin that they use to replicate the port so that they can make changes or take a look at how a change might help or harm the operations within there, and so they can go through multiple different scenarios to see how those happen. AI is used for predictive maintenance there, particularly with cranes. And they've calculated that it's reduced unexpected equipment failures by up to 20%, which for a port like Rotterdam is a huge amount of money. Autonomous drones are used to monitor the port facilities. So overall, it's just a much more efficient way of doing things. Um, Another example of a smart port is Port of Singapore. Here they use automated guiding vehicles to driverless vehicles to transport the containers. So that improves safety. You don't have people walking around in a yard. And if any of you have ever walked around a shipyard or a terminal like I have regularly, it's a dangerous place. There's a lot of heavy weight overhead. You've got to wear your PPE, your hard hat and everything else, and for good reason. So the less people are out there trudging around a port, the less likely somebody is to get injured. Singapore uses robotic cranes to reduce turnaround time for ships. They use AI for scheduling and smart berth planning. So they're able to allocate the berths based on ship arrival times in real time. So if somebody gets delayed by weather, if there's some type of issue with customs, if there's some type of clearance issue, then they will automatically account for that and reshuffle berth planning so that folks can be in and out, and so they don't have available unused berths for offloading and unloading containers. And they've seen a 30% decrease in container handling time, which is great, and as well as energy savings and environmental impacts. Here in the U.S., Los Angeles Long Beach uses the Port Optimizer platform, and basically they use data analytics for cargo movement. And so they use this platform to analyze the traffic flow of different containers and all the goods that are coming in and out, and automatically optimize and reduce delays within the port. They do use artificial intelligence for truck scheduling, appointment systems. They reduce waiting time. And frequently, if you're in these ports or you go to these ports, you'll see trucks waiting in line. And it happens in pretty much every port, large and small. You'll see these trucks waiting in line. And, sometimes they're idling, sometimes they're not. So being able to reduce the amount of time that they're sitting in line helps to optimize the system, reduce labor costs, and reduce economic or environmental impact. Automated drones and sensors are used in LA Long Beach to monitor inspections for safety, security, and also they use sensors to track air and water quality around the port. So they've reported that reduced truck wait times by 20%. And a 50% reduction in greenhouse gas emissions from port operations from their use of AI and green port initiatives. So what's next for smart ports? And this is slide 1 of 2. So what's next is that ports will continue to move toward these collaborative ecosystems. And so, as I alluded to, not only will you have smart ports, but you have smart ecosystems where more and more of the trains and the planes and the trucks are optimized as well, and even the cities. So you can start to look at places like Los Angeles where the port itself is its own environment, its own little city. But then there's what happens when trains come out of the port. What happens when trucks come out of the port? How does the traffic in and around Los Angeles at that day and time impact overall the optimization of the movement of goods. And so I can foresee that what's going to end up happening is that it'll be not just smart ports, but smart cities and smart countries. Um, Ports will also expand their use of Internet of Things. 5G is already prevalent, and that kind of revolutionized sensors for terminal operations and being able to track containers along with RFID systems. With Starlink and those types of things, there's a similar impact on the ships themselves to be able to uh, transmit data and upload data to be able to understand on the ship and on the platform what's going on within the overall ecosystem. There's also going to be a focus on resilience against climate change. So ports are going to invest in infrastructure to withstand any type of climate change as well. So again, we've kind of covered the greening of the greening elements, which is both economic and environmental. And the next is seamless integration with smart cities, which we've already talked about. And reducing urban congestion is a big thing. Overall supply chain efficiency and sustainable development goals will be better able to be achieved by using these smart ports. That concludes my session, and so now I'll answer any questions that may be out there. Okay. Let's see. Starlink. How's Starlink being used on ships? Okay, well, so what we're seeing is that Starlink does not exist on all ships right now, but we're seeing a lot of organizations invest in Starlink on their vessels to be able to transmit data. And one of the things that you can use Starlink for, certainly, and what we do at Mad Security is for those folks that have Starlink, we're able to get additional insight into their security operations on board the ship. For instance, we're able to get logs on and off the ship in a way where we weren't before. Before the ship would get underway, it was too expensive to have Inmarsat. The Inmarsat bills were really high. And so you had to wait basically until the ship got back to port to offload those logs for analyzation and alerts for analyzation. Or some of us were able to use that to prioritize and only put high risk alerts over those systems to reduce the Inmarsat costs or the SATCOM costs. And so with Starlink, we've been able to see that in some cases we're able to treat those ships just like they were an office, for lack of a better term. So we're able to get real-time alerting up and down the chain from high to low priority alerts, depending upon the bandwidth and the security operations needs of those ships. Let's see. Smart cities. So we're the question is, what are we seeing here in the U.S. as far as some of these smart cities? So we are seeing in some cases some of the larger cities be involved in the port operations and collaborating with the ports to be able to share data to reduce those costs. California is a big state for that, where we're seeing a lot of that occur. Smart cities are still a ways off yet, but certainly we're starting to see the advent of that. Rotterdam was a huge turning point with all of the smart technology they did. It being as large of a port as they are, they're definitely a world leader. So they continue to make technological advances. Hopefully that answers that question. Any other questions? Okay, well, hopefully this was helpful. And if you have any questions that I can answer, always feel free to reach out to me. Cliff@madsecurity.com is an easy enough way to hit me. And so feel free to reach out to me anytime. or go to the Mad Security website, madsecurity.com, and feel free to ask any questions there as well. If you have any topics that you'd like covered in the future for Maritime, please let me know. I'm always interested in trying to get people together to talk about these important considerations. So thank you very much. Have a wonderful rest of your day.